Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on partition equal subset sum. Let's understand it and start solving. And slowly we have reached 51st problem out of 75 total problems. Last time we have solved the word break. You can find it in the list. We'll mark it check. We'll start with partition equal subset sum. Okay, given an integer array nums, return true if you can partition the array into two subsets such that sum of the elements in both the subsets is equal or false otherwise. Okay, so we have 1 5 11 5 and we can partition them into two equal parts, that would be 155 and 11, and the sum of 155 is 11 and the sum of 11 is 11 as well. We cannot do the same for 1 2 3 5 since 5 plus 3 8 plus 2 10 plus 1 11. The sum is odd, so anyway it cannot be partitioned, right? Similarly, if we have an array something like let's say 4 4 2, we cannot partition this, right? Because yes, even though the overall summation 10 is even, we cannot separate them. If we pick 4 2, that is 6 and 4. If we pick 4 4, that is 8 and 2. Anyway, we cannot partition them into two equal parts, right? So before we start solving, please take a minute and think of the approach that you would take. Ready? Okay. Now one of the approaches that we can take is, or that we are going to take is, let's say the sum, let's say we consider this array. So we can say 1 5 11 5, right? Let's find out the total sum, that is total sum is equal to 22, right? That would mean that one subset should have the overall sum as 11, right? So our target sum should be 11. Now we just have to find out if there are elements in this array that we can use to form 11, and then the rest of the element will form 11 eventually. Okay, so we'll try to find out if making a sum of 11 is possible or not. Now in order to do that, we'll use dynamic programming. What we do is, let's say our target sum is 11, so we create an array bigger in size than the sum, that is bigger by one number. So let's say we'll create an array of size 12, boolean array. Okay, so I'll initialize all of them 0 0 0 0 0. How many are there? 1 2 3 4 5. Copy, oops, copy, 10 11 12. Okay, first one is for representing zero target sum. So if we have a zero target sum, we can always partition for 0, right? So we always mark 0 as 1. 0 is always possible, right? Now we have to see, is 1 possible, is 2 possible, is 3 possible, and we finally have to reach the target sum. Is 11 possible to be made out of the elements from this array, right? If in the end this last value from the array comes out to be true, that means the solution is possible. If false, the solution is not possible. Now if you see, 1 will always be possible since we have a 1 here in the array, so in the end 1 will become possible. Similarly, we have 5, so 5 is possible, so 0 1 2 3 4 5 is possible. Similarly, you can see 5 plus 5 plus 1 is 11, so in the end we'll have 5 plus 5 and 6 7 8 9 10 11 will come out to be possible. Now how we are going to reach this part of the code? We'll use the dynamic programming. We'll use from the most right side end, that is from the 11, and come down to the left side end. Okay, let's consider for now all of them are 0, and let's start coding. Okay, let's see. So what do we need in the beginning? First we need to find out the total sum, so we'll say calculate the total sum for int num from nums int, let's declare a total sum outside. because we would have to use it later as well. Int total sum is equal to 0. Okay, and here we'll say total sum plus equal to num. Okay, now we have the total sum. Now we'll check if the total sum is odd, that means the solution does not exist at all, right? If total sum is odd, solution, or we should write partition is not possible. So we can check if total sum mod 2 is not equal to 0, return false. Okay, now we'll calculate the target sum. Calculate target sum, that is half of total sum. So we can say int target sum is equal to total sum by 2. That's it. Now we'll create a boolean dp array for the solution. Okay, create a boolean array to memorize sub problem, right? That's why we use the dp. So we'll say boolean dp is equal to new boolean, and size would be target sum plus 1. Target sum in this case is 11. I'll just write it in comments for now, 11, and we create an array for target sum plus 1. Now we have, when we are solving with dp, we have to solve it in such a way that if the earlier solution is problem, based on that we build the next, right? Now we know that creating a sum of 0 out of this array is possible, right? By not choosing any character, right? By not choosing any element. So for this we initialize our first place. Okay, so we'll call initialization. It's always possible to achieve a sum of 0. So we can say dp of 0 is equal to true, right? Now we are going to iterate over the array elements from nums. So we'll say iterate over the array elements. Okay, for int num from nums. Now we are going to iterate in the backward direction. So we are going to start from 11 and check in the backward direction towards 0. Okay, let me comment for everyone. Iterate backward from the target sum to the current element. Okay, because when we have an element 5 that we are considering, we don't have to check for lower values. We'll only check from the target element, that is 11 till 5. Okay, to the current element. Okay, so we'll say for int I is equal to target sum, I is greater than equal to num, I minus. Right, now we'll check if it's possible to achieve the current sum using the current element. Okay, check if it's possible to achieve the current sum using current element. Okay, so we can say dp of I. So I in this case is starting from 11, so dp of I, that is this one, is equal to dp of I or dp of I minus num, right? So by this we are saying I minus num, 11 minus, let's say when we are at 5, so 11 minus 5 would be 6. Okay, 0 1 2 3 4 5 6. So let's say if 6 is already true, then adding num, that is 5, will actually give us true for 11 also, right? But in this case, what would happen is dp of I, that is 11, is equal to dp of I, which is 0, or dp of I minus num. Num is 1, right? So it will be 0 as well. So it will remain 0. Then we'll do I minus minus. I will come to this part. We'll check for this and the smaller one. This will still remain 0 since num is equal to 1, and all we are checking for is the current value and the value 1 previous to that. So all of this will remain 1 except for 1. Because when we come to dp of I equal to 1, we'll check dp of I or dp of I minus num, that is dp of 0. So this will become 1, right? At this point, we'll break the loop, we'll move forward. Now num is equal to 5, the next element. Target sum is equal to 11, we'll start from here. I is greater than equal to 5, right? dp of I is equal to dp of I or dp of I minus num, right? So 0 or 11 minus 5. So 1, 2, 3, 4, 5. This is also 0. So the sum will remain 0. Similarly, it will remain 0 for 10, 9, 8, 7. But when we come to 6, we'll check dp of I is equal to dp of I, that is 0, or dp of I minus num. So we'll subtract 5 from this. 1, 2, 3, 4, 5. This one is 0. This one is 1, right? So this one will become true. Okay. Now also in simpler manner to understand, from this given set of elements, you can make 0 sum, yes. You can make sum 1, yes, using 1. You can make 5 using 5. You can make 6 using 5 and 1, right? Similarly, you can make 10 and you can make 11. Okay. Now we check for 5. I is I minus minus, so I comes to 5. I will check dp of I is equal to dp of I or dp of I minus num. 1, 2, 3, 4, 5. That is true. So this will become true, right? But this is still false, right? This hasn't changed yet. But similarly, we'll move to our next element, that is 11. We'll check dp of I is equal to dp of I or dp of I minus num. So 11 minus 11 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1. And this one will get updated to 1. That means creating a sum of 11 is possible. And once we have finalized that creating a sum of 11 is possible, that means the rest of the elements will create the other sum, that is other half, which is 11. So in the end, we can simply return whatever value we have in the last target sum from the DP array. If it is 0, that means solution is not possible. The final result is stored in dp of target sum. Okay, so we can simply say return dp target sum. Okay, let's run it. Oops, somewhere something went wrong. Line number 10, total sum mod 2 is not equal to 0 if I don't know how come I wrote it FIR. Okay, if total sum mod 2 not equal to 0. Okay, let's submit. So though we have used dynamic programming, you may still find approaches better than this one. Okay, it beats 80% of the solution. So there does exist a lot of there would exist few approaches that are better than this one as well. Okay, yeah, that's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.